Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 977, squares of a sorted array. This is an easy level difficulty Leetcode problem, and the problem description is that we're given an integer array called nums, which is sorted in non-decreasing order, so basically in ascending order, and we need to return an array of the squares of each number sorted in ascending order. So that's the problem description. We're given an integer array and we need to sort the array. We need to square each number and return return all the squares in ascending order. So we're given an example. In this example over here, we can tell that we return the output because of 0, 1, 9, 16, and 100, because after squaring, the array becomes this over here, and then after sorting, it becomes this. And so, a naive approach would just be to go through the entire nums array, square each number, and then sort all the numbers. That's the naive way of solving the problem. The more optimal and more smarter solution to solving this problem, and also the solution that, for example, an interviewer would want you to give, is to be using a two-pointer solution. And let's actually look at why a two-pointer solution would work in this problem. So it's a bit hard to spot at first, but it's important to know that the largest squares will always come from the largest absolute values. So the largest square, so we're going to make some assumptions. We're going to say the largest squares always come from the largest absolute values. Where are all those, the largest absolute values? They're at either side, at either end of our nums list. And what's the last assumption we can make? We can say that let's compare the absolute of the left value and the absolute of the right value. Choose the bigger one. So choose the bigger one and fill out our result list. Fill out result list from the end to the start. So these are the three steps we're going to be solving to solve this problem. So we're going to be following to solve this problem. So we're going to have two pointers and square both the numbers, compare the numbers. Actually, we don't even need to square the numbers because we know a bigger number is going to have a bigger square. So we want to compare the size of the absolute numbers at either side and choose the bigger one, and then fill out our result list with the square of that number. So let's hop straight into the code. So solving this problem, we want to first create our pointers. Left pointer is going to be equal to 0. Right pointer is going to be equal to length of nums minus 1. Result is going to be equal to 0 times by length of nums. So we want to basically create a result list which has which is just full of empty zeros initially. And actually, let's times that by n and set n equal to the length of nums. And then we can set this equal to n minus 1, so we don't keep repeating length of nums. And we also want to fill out our result list from the end to the beginning, so we're going to just set that also to equal to n minus 1. So that's our auxiliary variables initialized. Now let's actually do the code. We're going to say while left is less than or equal to r, because we also want to consider the middle number. We could have an odd number of elements in our list. So we're going to say while left is less than or equal to right, if and again, now we're going to compare the numbers. We're going to compare the absolute values of each number. So we're going to say if absolute value of the number at pointer L is greater than the absolute value of the number at pointer R, well, in this case, we can say result position is going to be equal to the square of that number. So nums L squared. Otherwise, if nums R is greater than nums L, we can say result position is going to be equal to nums R times by 2. And remember, we don't want to forget shifting our pointers. So right minus equals 1, left plus equals 1. And also shifting our position. We don't want to shift up, we want to shift down because we're starting from the end of our result list and working down. And then what can we do? Well, then we can simply return our result list. So let's return result. Let's submit our code and check everything works. And it's taken a while, which suggests something might have gone wrong. And no, it works perfectly fine. So we've passed all 137 test cases with quite an optimal solution. So really, it's keeping those 3 steps in mind, understanding that the largest squares come from the largest absolute values. Those largest absolute values are on either side of our list, and then comparing those 2 values and choosing the bigger one. So what are we going to be looking at in terms of time complexity? Well, we are creating a result list which is going to be equal to n, where n is the number of elements in our list. So we want to have a time complexity of O of n as well as a space complexity of O of n. So O of n for both the time and space complexity. And with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.